This is a production of Cornell University.
So thank you. I'm actually very happy to be here. I, in addition to being a plant pathologist, have an administrative role, and it's been, to be quite frank, a rather rough administrative week. So I'm really happy to be talking about tomatoes and research this afternoon. So I previously taught introductory plant pathology, and one of the things I would always say is that tomatoes have about 100 diseases that attack them. But that seems like a lot, and it is a lot, so many diseases. The good news is that, the most common ones, there's probably only 5 or 6 really common diseases that we see each year. So coming down from 100, 5 or 6 does not seem so bad. I wanted to start with a bit of a timeline, because right now, this time of year, what we're doing in our research greenhouses is we're sanitizing. We grow all of our transplants for our research experiments in our greenhouses, and we want the transplants to be really healthy going into the field, because for my research, I want the plants to become infected with the pathogen that I inoculate with. So it's really critical that the plants are healthy going into the field. Of course, as a grower, it's also really critical that your plants are healthy going into the field, because if they start out unhealthy, it's not going to vastly improve. You want to start with the best possible scenario that you can. So I sanitize the greenhouse, and I'll show you a picture of that in a second, but we sanitize benches, we sanitize the floor. We have a concrete floor on the greenhouse that we grow most of our transplants in, but we also have greenhouses that do have gravel floors, and we would sanitize those as well. Trellising stakes, I will bring up several times, but sanitizing trellising stakes is key. And really anything that touches the transplant, whether that's flats or pots or anything that might end up touching a transplant, you're really going to want to sanitize. And then the other thing this time of year, or actually a couple of months ago, that you want to be thinking about is when you're selecting your cultivars. In particular, if you had a significant disease outbreak in your tomatoes last year, you're going to want to think about looking for resistant cultivars. And I know that you're going to tell me that the resistant cultivars are not the ones that consumers like myself always want to buy. But if you had an outbreak and had a lot of yield loss last year, a resistant cultivar, at least in part of your crop, is really going to help you out this year. So the other thing I always ask in my introductory plant pathology is, what is the best way to control plant diseases? And the students, 9/10 of the students will say you spray fungicides, and that is not correct. The absolute best way to control plant diseases is using cultural practices, which includes the use of resistant varieties that plant breeders have worked very, very hard to develop. And that is your first and best line of defense. So important strategies for disease control. I'm going to start here, and then we're going to get into some images of diseases. So starting with clean plants, that's clean seed. There are really beautiful extension publications on hot water treatment of tomato seed. I have helped tomato growers that are concerned in particular about bacterial diseases hot water treat their seed. And the length of time and the exact temperature are very critical. So if you are considering hot water seed treatment, you really want an extremely accurate thermometer and timer, because you don't want to leave them in that hot water too long. Clean your greenhouse and all of the materials associated with transplant production and field production, including trellising stakes, even if you had no disease last year, right? Because pathogens are tricky. They can survive in the greenhouse, and you might have had some bacteria on the leaves in the greenhouse, but you didn't see the disease. And then you put it out in the field and it was, okay, this might not be true for last year, but let's say it was really dry. That disease would never have developed, but that pathogen could still be surviving in the greenhouse. So cleaning the greenhouse every year, even if you had no disease last year, is really a great way to get started. The sanitizers work equally well as long as you follow the label, and really importantly, clean the debris from the greenhouse or the trellising stake prior to the sanitation. Because as soon as that sanitizer, whether it's a green shield or a xylitol, as soon as any of them hit organic matter, they're going to become inactive. So you want to clean up all of that plant debris, anything that might be covering up where the sanitizer might need to get to. The sanitizer will contact that pathogen, kill it, and then become inactive. We keep our floors clean, eliminate weeds. As I said previously, new or clean flats, and raised flats above the ground if you can, and always scout. So this is a picture of Holly Lang, a former technician, sanitizing our greenhouse. The benches that we had at the time, you can see they had quite a bit of rust on the frame. And so she would just take a pump sprayer and spray right along the edges and all those nooks and crannies where bacteria or fungal spores might like to hide. And she would spray each of the benches. She would also spray the grate, and as well as the floor. We would sweep out the greenhouse ahead of time to remove any organic matter. We would clean all of the surfaces. And then for flats or pots that might be touching transplants, we actually dip those into a sterilant such as Green Shield or xylitol. So this is a picture that I took in a tomato transplant production facility in California some time ago, but I think it illustrates nicely the idea of if there is a disease, one plant in this facility that gets a pathogen, gets a disease, with the overhead irrigation, how tightly packed things are, and the high humidity, that pathogen will be able to spread through these millions of plants really quite quickly. So scouting, and this person right here, I was able to talk to him. His entire job, 40 hours a week, was walking through the transplant production facility scouting. Identifying where there's a disease early on is going to enable you to get rid of that, get rid of the plants around it, because the pathogen has probably already spread to them, and move forward so that the rest of your transplants do not get diseased. And I realize that, you know, most of us don't grow 8 million tomato transplants at the same time, but the concepts are true whether you're growing 200 plants or 2 million plants. So pathogens can be seed-borne, which is why it's important to think about transplant production. One infected seed in 10,000 can start an epidemic in a greenhouse with these overhead irrigation systems. And the pathogens can spread rapidly, so scouting is key. So that's what I'm doing at this time of year. And sort of the next steps after getting the plants into the field are, okay, what diseases might we expect to see first? And one of the things we see first frequently in the year are bacterial diseases. So I'm wondering, and Kim will put up a poll, how often do you see symptoms like what you're seeing here on these tomato fruit? How often do you see those on your farm? Do you see them every year? Most years, occasionally, never, or you don't know? All right, it looks like we are stabilizing around some years. And a few folks every year, and a couple folks are fortunate that they have not seen this. So Kim can enter that and that. Everyone can see where we landed. Most people, it looks like, see bacterial diseases some years. All right. The three common bacterial diseases we have here in New York are shown from left to right. Bacterial speck, which is named because the lesion on the fruit is very small, like a speck. Bacterial speck, the bacterium that causes this particular disease, really thrives during cool seasons. Bacterial canker is the bacterial pathogen that over the years I've seen the most here in New York. Has a very characteristic lesion that I'll show several more times with that dark center. It can be tan to brown center with that white halo. It's called a bird's eye lesion. It's very common, as I said. Bacterial canker likes cooler weather, but it'll show up in most seasons unless it's extremely hot and dry. And then bacterial spot is the pathogen we see, the bacterial disease we see least frequently, and that's because it really likes the really warm, wet seasons. So when we get like hurricane remnants with those hot blowing rains, it's common to see bacterial spot. So how do we manage bacterial diseases? And I wanted to put this here before I show a few more images, because I think it's good to have some of these management strategies in mind. So irrigation management is key. And we want to water early in the day. And this is actually true for any, for management of any pathogen. The more dry a leaf is, the less chances you are to have a disease. If you water early in the day so that the plants are dry by nightfall, you're gonna then, if there is a dew in the night, you'll spread that leaf wetness out. You want dry leaves. You want good air movement, which helps keep the leaves dry. And you don't want to walk through the field or prune greenhouse transplants when the leaves are wet, because when those leaves are wet is when especially bacterial disease, the bacteria themselves can be on the surface of the leaf. They come out in the water. And so as you walk by, the bacteria are going to stick to you, and then you're going to transfer those to the next plants. As I said before, we want to make sure we clean the trellising stakes, and copper can help prevent spread. Amara, were you going to jump in? I saw you. You looked like you were going to jump in.
No, I turned my video on just to be more friendly.
Yeah. So,
Chris, can I ask a quick question?
yes, Marion.
How are the bacteria getting into the tomatoes?
So the bacteria, it depends on which pathogen we're looking at. And I'll show some images in a minute, but they generally will enter either through the a wound. So if there's an insect feeding or a hail damage, or the stomates, which are the pores on the leaves that enable the plant to breathe, or the hydathodes, which are tiny holes around the edge of the leaf. So bacteria are really tricky that way. And on the fruit, we actually know that the bacteria will get on the fruit and will enter when the fruit is very young, in little cracks that are in the fruit when the fruit is a very young age. I did not inoculate this particular tomato plant that has bacterial, this tomato fruit that has bacterial canker, but the trellising stake next to it had bacteria on it. And this picture just shows how we know that bacteria can transfer from the trellising stake to a tomato fruit or a tomato leaf. And in fact, I have a colleague at Ohio State who, the way that she inoculates her research plots with bacterial pathogens every year is to simply use the trellising stakes from the year before, right? So at the end of the season, she pulls up those trellising stakes, tosses them in the barn, the next season, gets them back out, uses them again, and that's all she has to do to inoculate her field plots. That should be enough to convince you to disinfect those trellising stakes. So what we did is we actually bought a trough that one would use for water for cattle. And we put disinfectant in that trough and use the trough. We dunk our steaks in that trough. We leave our steaks in the disinfectant, the sterilant, for about 10 to 15 minutes. And we want to make sure that all of the steaks are in contact with the solution. So we probably only put about 25 steaks in at a time, just to make sure that there's contact. I get asked a lot, how do you know for how long is that disinfectant usable? How long is it good? And I have not tried these, but I know there are test kits that you can actually use to see if your disinfectant is still effective. But we tend to use it for we use it for about 200 steaks, right? So we use it for 8 batches. We do clean our steaks first, so there's no organic matter left on them, but we assume that there's still organic matter in the nooks and crannies. I did want to get a few more images of the bacterial diseases before I move on. Bacterial canker, the bacterium that causes bacterial canker, is somewhat unique because it will actually travel through the veins of the plant in the xylem itself, the water conducting vessels, and it will clog those vessels. You can see on the edge of the leaf right here, this necrosis. And as I said earlier, the pathogen can actually enter in tiny holes that are along the edges of these leaves, and that's how it develops this necrosis. One tricky thing is that a lot of things can cause marginal necrosis on a tomato leaf, so that marginal necrosis by itself is not, oh, I have marginal necrosis, it's absolutely bacterial canker, because other things can cause that as well. These bird's eye lesions on the fruit are an absolute diagnostic sign. There's nothing else that causes lesions like that. This was from a farm that did not recognize that it had bacterial canker, and it just turned into a total loss of this tomato field. The plants wilted, and all of the fruit had some symptom, some lesion on it, which made it unmarketable. The other thing I wanted to show you was just sort of what does this bacterium look like? It's yellow and it's slimy. And so you can imagine how if that were in the water conducting vessel of your tomato, it might clog it up. All right, bacterial speck is the other bacterial pathogen that we have seen frequently in recent years. Until 2009, we really almost never saw it here in New York. In 2009, we had a very cool, wet season, and every year since then, we've had some bacterial speck in the state. As you can see, the lesions are very small, but do make the fruit unmarketable. It is particularly severe. You can see here, I like this image because there are a lot of leaves that don't have any symptoms, but then you can see there's one leaf that does have symptoms. And, you know, we don't yet know why it is that this leaf really, the bacteria were able to enter compared to the one right next door to it. But that's one of the questions that we're looking at. We know that bacterial speck, that actually all of the bacterial pathogens do have the ability to survive on farm. We also know that they can also and do also arrive in seed or transplants. All of the bacteria will spread by wind-blown rain and water splashing as well. And one of the things that I want to highlight, I frequently get asked, well, how come on my tomato plant, some of the fruit will have those bacterial spots and others won't? And the reason for that is the timing when the bacteria land on the fruit. So if the bacteria land on a tomato fruit when it's less than 1 inch in diameter, so less than roughly the size of a golf ball, you're going to end up seeing spots on that fruit. And the bacteria can actually enter even when the flower is wide open. That tiny fruit is just starting to develop. It can enter there, and those lesions will stay on the fruit, and that's what you see when the fruit is fully mature. Once the fruit gets to be larger than 1 inch in diameter, I had a student that graduated not too long ago, and he actually took the bacterial canker pathogen with a paintbrush and painted it on to all sorts of tomato fruits. And once those fruits are larger than an inch in diameter, it doesn't matter how many bacteria you paint on with that paintbrush, they do not get symptoms. So it's really, in terms of the fruit, the symptoms are, or the disease can only infect, the pathogen can only affect when the fruit are young. So as I said, sort of wrapping up my bacterial diseases, they're much worse, and this is true of most but not all plant diseases are going to be much worse in wet summers. We know our bacteria survive both in greenhouses and they can survive on farm over winter. They can arrive on seed. There are very limited options for bacterial diseases. And one of the things my group does every year is test potential new options for control. And I would say maybe 10 years ago, I was really excited because there was a company that was producing tiny viruses called bacteriophage. And those bacteriophage are super specific to one particular bacterium, and they'll kill it. So it's like a virus that goes in and only kills the bacterial canker pathogen. We tried it, but it didn't work. So last year, a different company had a new product, and I still feel like there's a lot of promise in this biological control strategy. And so the one we tried last year worked better than nothing at all. So that was good, but it did not work as well as the copper that we put on. So copper is the most commonly used control strategy. And bacterial, in terms of timing, bacterial pathogens can arrive any time of the season, but it is one of the diseases that you can see early in the season, particularly if it came through transplants. My lab has tested bacteria for copper resistance. There's known copper resistance in almost every bacterial pathogen. And we saw some in the bacterial spot pathogen. Bacterial spot, because it loves that warm, humid weather, is actually a limiting factor for tomato production in Florida. And we think that some transplants came up that had bacterial spot with some copper resistance, but we really haven't seen widespread copper resistance here in New York. I will say that in some instances, there can be too much copper put onto a plant. You know, in this case, the copper was not phytotoxic, but you can see that on the plastic is just blue with copper. And you know, the grower was worried about rain and had a history of bacterial diseases and was spraying copper on a five-day schedule. So when you do have bacterial pathogens, they can be devastating, and control strategies can be limited. All right. So if there are questions on bacterial pathogens, otherwise we will have a poll on early blight. How often do you see early blight on your farm? Marion, Abby, Amara, did I miss anything in bacteria while people are answering the poll?
Hey, Chris, it's Abby. I remember that at one point you were doing, I don't know, maybe it wasn't, was it black rot? I don't know if you did this in tomatoes, but you had a way to know whether the bacteria was being brought in on seed more frequently than overwintering. And I don't know if you have a sense of that with the tomato bacterial diseases.
Yeah, so we do for bacterial canker. The bacterium that causes bacterial speck, they all seem to be it's really hard to differentiate them. Bacterial canker, we do know that it's about a 50-50 mix of the pathogen overwintering on farm and new strains coming in each year. And for bacterial spot, I have a student that's working on that right now. We don't have quite enough isolates of the pathogen yet to do that study.
Okay, thanks.
Early blight. Everyone sees it some years. In my plots and in my home garden, I seem to see it every year. So the trademark symptom of early blight is this target-shaped lesion on the tomato leaf. And early blight also goes to the tomato stem. And some people say it looks like a target on the stem. I have a bit of a harder time always seeing that. But on the leaves, you get these very characteristic target-shaped lesions. When early blight is young, it's really hard to differentiate from other pathogens. And I will show you an example of that in a second. So when you see early symptoms, there are small dark lesions, which there are several other pathogens that also cause small dark lesions, including bacterial speck and septoria. The older leaves have these older lesions are target shaped. And early blight, the fungus that causes this disease, the fungus has a kind of cool name, Alternaria tomatophila. I like that one. It survives in the soil. And you'll first see it on the lower leaves, and it'll splash up from the soil onto those lower leaves. So rotation is key because the pathogen is in the soil. If you can rotate out of tomato, and this particular pathogen can go to potato, and there's a super closely related pathogen and they can both sort of go to potato and tomato. So you're going to want to rotate away from potato and tomato. And they're going to be worse in wet weather because, well, pathogens like wet weather, but also you're likely to get that splashing up. So in addition to rotation, anything you can do if you have a weed cloth or a straw mulch or something on the ground to try to prevent splashing from the soil up onto the plant, that's really going to help you control early blight. So these are young early blight lesions, small dots on a leaf. And they look remarkably similar to these septoria lesions and these bacterial speck lesions. So when someone brings a leaf like this into my lab, I can't differentiate the three when they're that small. I actually have to isolate and see which pathogen that we're working with. Early blight, as I said, is an annual problem. You'll see lesions, as you can see in this plant, starting on the lower leaves, but then they'll move up rapidly. And it's that splashing up the plant from either overhead watering or rain events that really will move it through the plant quickly. And it can take a plant down. And I'm including septoria here. I'm gonna talk about management because you manage them both in a similar manner. So have you guys seen septoria on your farm? Septoria leaf spot is these tiny spots here, as you saw on the previous slide. The characteristic lesion that you see over here on the right-hand side is that dark ring with a tan center and tiny black spots. And there's nothing else that looks like an old septoria lesion. And it can be confusing with early blight, especially at some of the younger stages. And a lot of times you're going to see both septoria and early blight together. And then it's like, I'm not sure. And that's usually because it's both. And I think that shows up in this poll because a lot of times you might be seeing it and you're like, I'm not sure. I had brown spots on my leaf, but I'm not sure what fungus or what organism was causing these brown spots. So, whoa, sorry about that. There we go. Septoria leaf spot, as I said, it survives over winter in the soil, just like the early blight pathogen, splashes up onto the leaves. These are, again, those characteristic lesions. They're getting a bit older. You can see this tan spots starting to develop in the center. As I said, it's confused with other spots. And the other thing that's tricky about it is that it's seen mid to late season, which is the time when you're going to see almost all of the tomato pathogens showing up. So that can make it tricky as well. Much like early blight, it thrives in the wet years as the fungus splashes from the soil to the lower leaves. I was visiting a grower, and actually it might have been with Abby, And there was one field on their farm that they took us to because they knew. So when I visit farms, people tend to show me their most diseased plants. And this particular field was in a remote area of the farm and it had been forgotten about. And so no control strategies were used. And the entire field was destroyed by the combination of septoria and early blight. And you can see in this field, they did have a black plastic mulch and a straw mulch between the rows. And even with that, the fungus was able to move from the soil up onto the plants and completely wipe out this field. It was a total loss. It was really sad. This is an image of that field. You can see they tried to go in and see if they could harvest anything, but in fact, it was a total loss. So managing early blight and septoria. Rotation is important. Scouting is important because you're going to want to see, oh, I have a lesion right on the bottom of the plant. You can remove those lower leaves. That will help. And as soon as you scout and see that first lesion, if you're going to implement a control strategy, whether it's one of the effective fungicides, there are biocontrols that I haven't tested them, but from what I've read have mixed efficacy. You know, you're going to want to do that early on. So you're going to want to scout, oh, there's a lesion. Now is when I need to really start focusing on disease control. There are tolerant varieties. The varieties that most growers commonly grow, because that's what the market wants, are susceptible, but there are tolerant varieties available. All right. That was early blight and septoria. Tomato leaf mold. Have you guys seen this on your farm? My lab only started working on tomato leaf mold 5 years ago. And it's really because of the increase in high tunnel tomato production in New York that we started working on tomato leaf mold. And in this group, it seems that most folks, thankfully, have not seen tomato leaf mold. But the person who sees it most years, or the people that see it most years, I'm guessing that you have some high tunnel tomato production, because that's where we see it most often. So these are our research high tunnels. And so we were able to do tomato leaf mold experiments in our research high tunnels. We could inoculate plants, which I would never want to do on a grower farm. But we did several different research projects on tomato leaf mold in our high tunnels. And this is Kelly inoculating some of our plants. Tomato leaf mold is common in high tunnels because it likes hot and humid conditions and it likes cool nights. And that's exactly what you have in a high tunnel scenario. If you have plants in the field and it's a rainy season, you're probably not going to see leaf mold. It just does not like the rain. Nope, don't want my leaves wet, which is unusual for a pathogen. So it likes those hot, humid conditions, and it actually needs very high humidity for those spores to germinate and attack the plant, but no rain. It can spread rapidly. You see on the upper leaf surface, you see these yellow spots, and then on the lower leaf surface, you can see this brown to gray. I think people tend to call it sort of an olive colored fuzz. Those are actually all spores of the fungus. And there are so many spores that once it gets started, those spores just can spread like wildfire through a high tunnel. And we tend to see this mid to late season because the pathogen will survive over the winter in the high tunnel on plant debris generally, but it takes a while for it to get established and then move throughout the high tunnel during the season. So how do we control tomato leaf mold? Well, as I said, it overwinters in the tunnel, so we remove debris, and I know this can be difficult for growers, but rotating the high tunnel out of tomato will really help reduce the incidence of tomato leaf mold, especially since it's surviving in that tunnel.
How long, Chris? Is 1 year enough, or do you need more than one?
No, that's a great question. 1 year at least from what I have read, we haven't done the rotational studies, but 1 year should be enough because that tomato debris breaks down fairly quickly.
Yep.
If you have some really big stems, it might take longer, but generally 1 year is enough. One of the I don't know, drawbacks is not the right word, but generally, if you have high tunnels, you might have 3 or 4 next to one another. And you can imagine if it's hot out and you roll up the sides and you have this many spores of the tomato leaf mold fungus in one tunnel, they can spread pretty rapidly to the one right next door to it. So that if all of the high tunnels are in a line, it can be tricky to try to rotate away or keep one tunnel leaf mold free. One of the places when I'm scouting a high tunnel, if I see that there are sun gold fruit, which I am a huge fan of the sun gold tomato, I will go and scout those plants first, because in any given high tunnel, the sun gold is going to be the cultivar that gets the tomato leaf mold first. Sadly, it's incredibly susceptible. So I did want to show a little bit of data on our high tunnel leaf mold trial. I had a student that recently graduated that did a lot of work, and we made some progress understanding the leaf mold that we have here in New York. And there was some concern. There are tomato varieties that are grown in high tunnels that are sold as resistant to tomato leaf mold. And there was some concern that the resistance might be breaking down. But in our studies, the 4 cultivars that are targeted as resistant to tomato leaf mold were resistant in our study as well. So in this graph along the x-axis, we have the tomato cultivars that we trialed, and we rated at 4 different dates. So the blue bar is the first rating, the orange bar the second, the gray bar the third, and the gold bar the final rating of the season. And on the y-axis, we have the percent disease from 0 to 100%. So you can see by the final rating, some of the cultivars in our high tunnel had a lot of disease. But the good news was there were cultivars that did have resistance as well. So that was tomato leaf mold.
Chris, can I ask you one more question first?
Yeah.
Could someone plant a resistant tomato variety instead of rotating out of tomatoes altogether?
So if your only focus is tomato leaf mold, then yes, absolutely. And we know that the pathogen has been in high tunnels in New York for a long time, making lots of spores, and we have not yet seen the pathogen mutate to overcome that host resistance. However, we also know that there are other pathogens, soil-borne pathogens that will build up and can wipe out a tomato crop. So it is good to rotate if you can, especially to get away from some of the soil pathogens that you might have and some of the soil insects that you might have in that high tunnel. And sort of along those lines, for reasons that I'm very curious about but do not yet understand, there's a disease called white mold. And in tomato and pepper in high tunnels, it seems to almost be worse in high tunnels. It survives in the soil as well. And I'm really wanting to do some studies to try to understand why it is that the high tunnel environment is worse for those particular soil-borne pathogens compared to the field environment. As an aside, questions to be answered. So,
Chris, I have another question about leaf mold. Can keeping the air moving in a high tunnel, is there any kind of like air movement or air or humidity management techniques that can contribute to management?
Yeah, so that would be spacing of rows.
Yep.
When for sure, one of my most interesting memories of tomato leaf mold was I was in the North Country visiting a grower, and walking through the tunnel, and tomato plants, this was in August, and they're huge in high tunnels by then, and the rows were very close together, so I was actually walking sideways to get through the row. And when I came out of that high tunnel, I was completely covered in tomato leaf mold fungus spores. And that just sort of reminded me, anytime I think about row spacing in high tunnels. And I talked to the grower, and they said, well, I really want to have as many tomatoes as possible because I want the biggest harvest, because I need my farm to be profitable. But reducing those number of rows and giving the plants a bit more space, pruning out to increase the airflow within a plant, will all help reduce not only leaf mold, but any of the other pathogens that you might have.
Thanks.
So I would say 5 years ago, I would lead off every single tomato talk with late blight, because it was by far and away the biggest issue for tomato growers in the state of New York. They were fearful of it. And just thought, wow, if I get late blight, my crop is wiped out. And over the past 5 to maybe 7 years, the amount of late blight that we've seen in tomato in New York, or even in potato in New York, has really declined to the point where I am now including this and as the last disease that I talk about. Which is interesting. So people see it some years. If you have late blight, it's definitely going to impact your farm. In this slide, I wanted to show a diversity of the symptoms that we might see in a young tomato fruit. You're going to see a lesion like this brown lesion on the left-hand side. You frequently don't see as many of the pathogen spores on the younger, very green fruit. So you'll see a brown lesion out, like the picture here on the left. This leaf here in the center is an image that I frequently use because it's like the characteristic image of tomato late blight, that just millions of spores of the pathogen that show up on the underside of the leaf, and they're windborne, fly through the air, and can cause a huge amount of disease in a relatively short period of time. The pathogen can also attack the stem of the plant, and you can see here on a tomato stem, here's a leaf lesion, here's a stem lesion with so many of those white spores on the stem. And then in a ripe fruit, this is sort of the extreme close-up, but again, you can see that the pathogen is just really devastating that ripe fruit. So late blight is caused by a water mold. It looks like a fungus, but it's actually quite evolutionarily different from a fungus. And there are a couple of things that make that really important to understand if you're growing tomatoes. And one of those is that this particular, water molds in general, will go completely crazy in cool, wet weather. And in this image that I have here on the left, at first you look and you think, oh, that's a healthy tomato plant. But when you look at it closer, you can see that there are lesions on the leaves of these tomato plants. And this is probably not yet close to 5% of that tomato plant has some late blight on it. And my lab has done quite a few studies that once that tomato plant gets to 5% disease, which is really not very much, it's nearly impossible to control this pathogen, especially if it rains. So that's why, we're all so nervous about late blight. If you have 5% bacterial disease, you can still think about slowing it down, but wow, it's really hard to slow late blight down. The lesions can grow really rapidly. It's so common to hear people say, you know, I was in the field yesterday and I didn't see it, and today the plants are dead. And they can grow really rapidly. It can spread fast, and it will attack, as I showed earlier, the leaves, the fruit, and the stems. Back to that characteristic white sporulation. And I thought I would spend a second talking about that, because this is a close-up of those spores. And what they do is they're formed overnight. And in the morning, when the humidity decreases, the sun comes out, those spores actually twist in the lower humidity and twist their way right off the leaf into the wind of the morning. And they spread to other leaves in the same plant, other plants in the same field, and the fields next door. We know that we need to worry about where is that original late blight inoculum coming from. And we also know that the pathogen is not very good at surviving the winter here in New York, which is a really great thing about winter. It kills late blight for the most part. One of the ways that it will survive the winter here in New York is in potato tubers that are not harvested. If a potato field got late blight, this pathogen goes to both tomato and potato, also petunia. And this is a potato tuber that is infected with the late blight pathogen. If this tuber sprouts, that new sprout will have late blight and it can spread. So it's really important. Sanitation is so critical for this particular pathogen. I wanted to highlight, I encourage you all to go to the website called usablight.org. It has lots of resources on late blight, and you can sign up for text messages that will actually tell you if the pathogen has been identified in our region of New York. In addition to that, if we identify late blight in New York State, any of us, we push that out through social media and all of our weekly newsletters. Late blight is somewhat unique amongst plant pathogens because it's characterized by strains. So you saw all of those spores. Those spores are all the same strain. They're all identical. And if the pathogen overwinters in that potato tuber and comes back the next year, it's still the exact same strain. And since 2011, we have had the same strain in the state of New York, and its name is US 23. And there are some really interesting things about this strain, which I think is why we have not seen late blight as aggressive as we had maybe 5 to 10 years ago. It's sensitive to the fungicides that can be used to control it. It's more aggressive on tomato than potato, so you're less likely to get those overwintering potato tubers. And a nice thing about it is we've done studies that show that copper can control this particular strain if the copper is applied early. So even though we have not had much late blight recently, we still need to be really vigilant. And the last thing that I wanted to show was that there are some tomato varieties that are resistant to late blight. And this picture of the variety trial that we had, these are individual plots here, and those plants are flat out dead. But you can see that there are plots where the plants are still alive. And that's really exciting because if we know if let's say 2022, we have a horrible outbreak of late blight, and we think that there will be late blight in 2023 as well, you could plant some of these resistant tomato cultivars knowing that even if there was late blight, you would get a tomato crop. It might not be your favorite cultivar that you've ever eaten in your whole life, but you would get a tomato crop. And the genes are known that enable this resistance. They're called PH2 and PH3. And here are some of the varieties that are resistant to late blight. And it's, some of them are ones that are now grown. So we were really happy to see that some tomato varieties were holding up against the most common strain of late blight. So controlling late blight. Using those resistant varieties, scouting is key. You have to catch that so early, especially if it's a cool and wet season. If you're going to use fungicides, there are effective fungicides available. Rotating fungicides is key. As I said, copper has some efficacy. Importantly, if you think you have late blight, let one of us know. We'll get a sample and we'll make sure that it's late blight and help with any issues you might have in controlling the pathogen. It'll spread quickly to other plants and to other fields. So remove and destroy infected plants as rapidly as possible. So we're back to the best way to control plant diseases. Cultural practices are your first and best defense. I hope I've outlined some of the cultural practices that you can use. And with that, I will thank the people in my lab that did the work, the growers that led us onto their farms, my CCE and IPM colleagues, and all of our work is funded both by the state of New York and by the USDA. So thank you, and I will take questions.
Great. Thank you so much, Chris. Yes, if anybody has any questions, can you please put them in the chat? I have a quick one to get us started with. I know we had a question yesterday. Someone was asking about when they see diseases, it's usually too late. Do you have thresholds for the different diseases that people should be looking for? When do they need to act?
Yeah, there are thresholds for many of the diseases. Those would be listed in the vegetable guidelines, but generally, you know, generally it's, well, so if it's on your farm, if it's a bacterial disease or early blight septoria, I would say as soon as you see lesions in the plant, that's going to be your threshold. If it's late blight, your threshold is if it's in the county, right? So you hope that your farm is not the first farm in the county to have late blight, but that's one of the reasons that we really want everyone to scout and let us know, because once there is a farm in the county or a nearby county that has late blight, that's going to be our threshold to start thinking about the best management strategies.
All right, great. Are there any questions? I don't see any yet in the chat. If anybody wants to write in their questions, or more than happy to unmute yourself if you would like. You can ask questions too.
So I had a question about, I think this is in relationship to high tunnels, but if you plant spinach in the fall after tomatoes and harvest in the spring, harvest that spinach and then plow under, and you plant again the next season, is that considered a rotation? So, you know, you took your tomatoes out in September, you put spinach in, and then you want to put tomatoes back in April. Is that considered a rotation? And, you know, I think my answer would be no. You really need a season, you know, a season out of tomato. It is possible with the tilling, if you're really getting rid of all the leaf debris, that you might not have a leaf mold issue. But in terms of some of the soil pathogens, I would say stay a whole year out. So 40 sun gold tomatoes in your high tunnel. First off, please invite me over. I love them. And recommendations to avoid leaf mold. So, you know, that air spacing is critical. And the most effective thing so first, air spacing. Second, scout. Be on the lookout, and when you scout it, it's actually fairly easy. When you're looking across the high tunnel, look for anytime you see a yellow spot, and yellow spots can be caused by a lot of things, but one of them is leaf mold. So then you see that yellow spot, you flip the leaf over and see if you have that gray mold. And then the other thing is that if you are planning to use a control strategy, you're going to want to start as soon as you see that first lesion. And so scouting is really, really key. But yeah, that making sure that you're pruning, leaves, the lower leaves, get rid of those. So there's more airflow, and that should be good. Abby is also, yes, if you
Yes, share them with the IPM house.
So Chris, I had a question about fungicide strategy for late blight, because I know that, so mostly it's US 23, and so going in with with mefenoxam is
Yep.
probably the right thing to do.
Yep.
Sometimes I think growers want to wait and find out if it's US 23, but would you recommend that they just go ahead with the mefenoxam whether they know or not if it's susceptible?
Yeah, so if the late blight is in the field,
Yeah.
then yes, absolutely. Because in 11 years, the predominant late blight we've seen has been sensitive to mefenoxam. So
Yeah.
absolutely.
And then you also mentioned fungicide rotation.
Mhm.
So I know that, so in general, is there like a class of fungicides that's, better in rotation with mefenoxam? Like, should it be translaminar, or what is it about a good rotation fungicide would you recommend?
Yeah, so I think that translaminar, yes. Those fungicides that are effective on the oomycetes, the Revis, the Presidios, the Arondis, right? They tend to be really expensive, and so you want to use those, on a limited basis, because we don't want resistance, but also because they're very expensive. So I think that alternating something that's translaminar and affordable with something that's more expensive is the best strategy. And particularly with this US 23, we have seen success with that. But those, the Ranman, the Presidio, the Revis, the Arondis are all very effective.
Okay, thanks.
Chris, you have one more question, but I also know you have to hop off. So if you have a chance to answer it.
Yep. Biologicals. Yeah. So we, biological fungicides for bacteria, we have trials every year. We had last year, we had the phage that I talked about. We also had double nickel, and double nickel after copper, double nickel actually worked the best, and that's a bacillus, and that was effective. We have tried regalia against bacterial diseases, and we have not seen any efficacy. We've also tried oxidate. We tried lifeguard. We've tried a lot of different products, and so far, bacteria are really hard, but so far, the double nickel, we've seen the best sort of, it not as good as copper, but in that next best category. And we'll be trying actually additional biologicals this year. I'm hopeful that, that there is now a group of scientists that are studying, what can really survive on that leaf surface. And, if we can really learn about what survives on the leaf surface, or how do we enable those biologicals to survive on the leaf surface, I think that will really help propel biologicals into a place where we need to find ways to help the biological survive and outcompete that pathogen.
Great. So we're going to be going over nutrition and fertility management for tomatoes in general, and then as I go through the talk, I'm going to try to be pointing out how it relates to IPM. So as we go through this, feel free to put questions in the chat. We'll get to those questions at the end of the session. So here we go. Fundamentals of nutrition is a place I always like to start. So we're going to go over the plant needs, the relationship of pH and soil fertility, and then also uptake inhibition. So what does a tomato need? This is pulled straight out of the recommendations or guidelines that Cornell puts out. And right across the top, we'll see that it's based for soil for transplants into bare ground. We don't really, I don't know anyone who does direct seeding in New York. We have bare ground transplants, and then we also have separate recommendations for transplants in plastic mulch. And the reason they're separated out is not because the overall total recommendation is different. That is the same, like you see in the blue. It's because what you do at broadcast and disking is different. When plants are on plastic mulch, they very often have trickle irrigation underneath. And so we're going to spoon feed those plants throughout the season. That's why you're broadcasting less in. Right across the top, we see a range of nutrient levels for potassium and for phosphorus. The largest number, that's what the plant needs. The medium and high, that's adjusting that recommendation downwards based on your soil test. So that's how you read these if you have it. And I said soil test, right? So how much do you add? Very much so, the management of your fertility should always be based on a soil test. You want to be testing your soil at least every 3 years. If you've made some sort of change to the soil, either adding a lot of amendments, or maybe you had the field manured last summer, your early crop of peas came off, you had the field manured, or if you've done a lot of pH adjustment, you want to retest. So every lab will have a slightly different extraction method. The important thing is that you're looking at the pounds per acre or the sufficiency bars. And then if you switch from labs to lab, it's the numbers, the values may not line up, but the sufficiency bars will. So very quickly, we can look to see that this field is very high in phosphorus, it's high in potassium, very high in calcium, and high in magnesium. Overall, pretty good fertility. 4 things you should check out in addition to those bars. You should check out the soil pH. That's going to give you a lot of information about what nutrients may or may not be available. You want to check out the percent organic matter, because that's related to so many things, but in terms of fertility, it's related mostly to nitrogen cycling, and it's related to the soil's ability to hold on, store nutrients, and then give them back up later. Your soil test should always go in with a name, the series name of your soil. If it goes in with a name, then the recommendations coming out are going to be better tailored to your soil. The soil name tells the lab if you have a clay soil, a sandy soil, something in between. And then at the bottom, the lab is giving recommendations for what you add. You'll see that labs almost always recommend 50 pounds of phosphorus for a tomato crop. And we'll get into why that is. Even though the phosphorus is very, very high, lots of labs will recommend that because they're trying to overcome a temporary deficiency caused by cold soils. And that's a management decision that, along an IPM standpoint, might not always make sense. So we always want to aim to optimize things. The IPM is just as much about prevention as it is about sustainability, right? And so optimizing your pH and fertility makes a ton of sense to do that. So I'll start with this little graphic down here. This is a barrel. It's a very common analogy for how you think about fertility and what's limiting your crop. Every stave in the barrel is a different nutrient. Along the front, they've written the macronutrients. Along the back, they've written the micronutrients, and inside you fill it up with water, and the water is your yield potential. Your yield in terms of nutrition is only going to be able to go as high as your most limiting nutrient, and that's where the water is spilling out. In this case, it's potassium. I particularly like this barrel because oftentimes I think in tomatoes, our yield and our quality is more limited by potassium than by anything else. So when you have fertility that's too low, either your gross fertility, so that's your overall plant fertility, or your specific fertility of one nutrient, you end up with plants that are stressed in some way, and stressed plants are more susceptible to diseases and insects. Insufficient levels of fertility for specific nutrients can often interfere with fruiting and fruit quality. And this idea of sufficiency also applies to water stress. So that's going to mean that, yes, we're talking about fertility, but if your plants are constantly going through drought, flooding cycles, they're not functioning very well. And so you've created an artificial temporary inability to get nutrients. In terms of pH being too low, we often find that when the pH drops, the macronutrients become unavailable. They're present in the soil, but the plant can't get them. and that the micronutrient availability in the soil goes way up, and that can cause some toxicity problems. On the flip side, if we're running too much infertility, too high, very fertile soils, yes, the plants are doing really well, but as you continue to put more fertilizer into that soil, you're really wasting money, especially this year. Fertilizer costs were up 80 to 100% over last year in Western New York, and that was as of mid-February. They've continued to go up. This is not the year to be excessively applying fertilizer from an economic standpoint. If we get too much of certain nutrients, we can start seeing some uptake problems caused by other things. So this is where we start to see some inhibition and some competition. One example of this is if you are fertilizing very heavily with a NH4+, so an ammonium style fertilizer. The ammonium is in competition with potassium for uptake in the soil. And if you give your plants a giant slug of ammonium, you can cause a temporary decrease in the availability and uptake of potassium and a temporary insufficiency in your plants. Instead, if you're feeding with nitrate, NO3- format, the plant uses that much more efficiently. It's not competing for uptake. I'm a weed scientist. I always look at how can we control weeds with our IPM, with our IPM toolbox. And one of the easiest things we can do is not feed them. Weeds love fertility, and they're so much better at using it than most of our crops. And so they are hoarding it in, especially pigweeds. They're going to collect more nutrition than they can possibly use, and they hold it so other plants can have it, but they're also growing really big, setting lots of seed. So it's a strong IPM tactic. Too much fertility can favor certain pests and diseases. I'll give examples of that later. It also interferes with fruiting and fruit quality and is environmentally irresponsible. If we look at pH, as pH gets too high, we tend to see micronutrients. They're in the soil, but they're no longer available to the plants, and we start to see deficiencies. This is really common for manganese, it's common for zinc, and it's common for iron. And the place that we see those problems is in the transplant production stage, when we're not actually using soil, when we're using some sort of starter mix. The pH rises in those, and we start seeing yellow in the new shoots, slow growth out, diminished leaf size. Those are micronutrient deficiencies in the transplants because the pH of the growing media has gotten too high. Actual micronutrient deficiencies in the field are very rare. Outside, I've never seen it. It does happen in tunnels from time to time because the pH of the soil has gotten too high. So I keep talking about pH and nutrient availability. This is the chart that shows it. Across the bottom, we've got the pH of the soil, and each of these different color bars is a nutrient. The top set up through magnesium, right about here, halfway down, those are the macronutrients. Below that are the micronutrients. And you can see most of our tomato crops, most recommendations say around 6.5. And at 6.5, the width of the band that's available to the plants really matches how much that they need. And so this is why we're aiming at 6.5. It naturally balances the amount of nutrition that the plants need against the availability of those nutrients in the soil. We can have all the fertility we need, but if the plants can't get at it, it doesn't matter. So I always like to look at what could be inhibiting the uptake. I keep talking about tunnels because a lot of tomatoes end up being grown inside. So it's very common in tunnels that we get an accumulation of salts, and they rise up. They're going in with manures-based compost. They're going in with poultry-based fertility pellets. They're going in with our liquid fertilizers. Those rise up through the soils, water evaporates, leaving the salts, and salts, they change the osmotic pressure, and they start inhibiting the root's ability to pick up nutrients. The other thing in the field, compaction is huge. And so this is a giant wet spot. Someone decided I really have to drive through this. I can't find another way around, and just compacted this soil. You already had drainage issues. You're just going to keep on causing more drainage issues and more uptake problems. And so a lot of times fertility problems will chase water issues or chase compaction issues. Other things that inhibit nutrition and fertility from an IPM standpoint, if I'm seeing a fertility problem and it's not uniform, okay, fertility problems caused by feeding are uniform across your field. If it's not uniform, then I want to check out the roots in that area, especially if it's kind of like a circular pattern. This is a nice healthy tomato plant. in case you haven't dug up roots of one recently, that's what you want. But things like nematodes can have a big impact on the apparent nutrition status of your plant. So can root rots. Fusarium and verticillium are two wilts. We see verticillium sometimes in high tunnels. It's oftentimes because we're seeing different heirlooms being grown in there that don't have the genetic resistance to it. Verticillium is going to darken up the veins. And so we test for it by splitting the veins. If you've ever raised an eggplant, you will know what verticillium wilt does. It takes out half a leaf or one branch with wilting and yellowing and then scorching. Fusarium wilt is more of a generalized yellowing that eventually progresses to a scorch and a wilty plant. This can be confused sometimes for a nitrogen deficiency. Both of these will inhibit how well the plant's functioning, so you get a appearance of a nutrient deficiency. Any questions at this point? I can't see the chat, so are we good, Marion?
So far, so good. Yep.
Okay, cool. So the other thing with optimizing is the timing and the ratios of what you're feeding. So plants really are, they are feed me now. They have a generalized growth curve, and their growth curve follows the uptake curve, right? So in general, it's this S-shaped curve. They have this lag phase when they're little, a rapid growth phase when they have a high nutrient demand, and then their nutrient demand levels off. So let's say this is nitrogen. We have these little baby transplants, they're growing, but they're not really taking off yet. We get into the quick, vigorous growth phase. That's when you want to time your nitrogen feed, right here. This is a reason why the recommendations for tomatoes under plastic said that you're going to cut your fertility back, because we're planning, under plastic, we often have drip and you're spoon feeding. The whole purpose of spoon feeding is not to waste your fertility down here, is to feed it when you have much more fertilizer use efficiency and target the plants in their developmental stage where they need that. So if you miss these growth curves, you could be stressing your plants. If you give a lot of your nitrogen broadcast in the field, not only are you feeding your weeds, you're also increasing the chance that that's going to leach out with spring rains. And that translates to stress, loss yield. If you miss the shift in the potassium uptake needs, then you're going to be leading to poor fruit quality. And so potassium has a delayed shift. We'll switch to the other side here, talking about balance in the center. Tomato plants, when they're young, you want to be feeding primarily for nitrogen management. For NPK, you're feeding mostly for nitrogen management. As they begin flowering, you're feeding that plant for potassium management. They have a much greater physiological need as they flower, as they set fruit and need to load sugar into those fruit. If you miss that shift, that's where we tend to see a lot of fruit quality issues begin to develop. And that's where we have problems, particularly with determinate tomatoes, where they go through their first fruiting and they're fruit very heavy, but then they really peter off throughout the season and you struggle to keep those plants going throughout the year. The other ways you want to balance, you want to make sure that your macros and micros are balanced. We can get deficiencies in both micro and macronutrients. In micronutrients, we're very prone to getting toxicities. The plants do not need much at all. For example, boron. Plants need like a pound to the acre. If you try and feed boron to your plants, it's extremely easy to poison them accidentally by giving them too much where it goes toxic. For that reason, micronutrients we try to manage with pH. We optimize pH to manage our micronutrients. If you can't correct that with pH, then you would foliar feed something like a chelate. Chelates are designed to be safe for plants. They're very low application rates, and they're also designed to move into the tissue. And so that's a time when foliar feeding makes a lot of sense. When foliar feeding does not make sense is when you're trying to feed a macronutrient. Plants are designed to take up nutrients through their roots. Leaves are designed to keep things out. When you foliar feed a macronutrient, you often get a very quick, rapid, satisfying green up effect. But that is temporary, right? That's why you have to foliar feed every week, every couple of days. That green up doesn't last. And when we look at the tissue testing, when we look at the research on it, we find that foliar feeding is actually much more inefficient in terms of what the plant can take into itself and incorporate.
Elizabeth, go ahead, Marion.
No, I was going to say you did get one question. If you want me to interrupt you,
Sure.
Can you only feed through drip and not broadcast any fertilizer?
Oh, you can absolutely broadcast. Yeah, you can absolutely broadcast. Usually people who are broadcasting, they're open field tomatoes, so they're not on plastic, or they're broadcasting before they form up their beds, right? Because you
Elizabeth,
broadcast.
the question was about not broadcasting and only foliar feeding, right? Yes, I think so.
Only foliar, only
Yeah,
foliar,
so-
only drip.
Can you only feed through drip and not broadcast any fertilizer? That's the question.
Yes, you can. And you can do that. Most growers will start off still broadcasting a little bit as they learn to manage the nutrition only through drip. So if you've never done heavy management of nutrition through drip, maybe broadcast some a little bit to start. People who have been raising in tunnels or greenhouses for a long time, they won't broadcast that much at all, if any.
And would that depend, Elizabeth, on whether you had sufficient nutrients, like that soil test that you showed? You were sufficient for a lot of nutrients, so it seemed as though that would be a good field to not, possibly not broadcast in, but use the drip more.
Absolutely, and that actually was a test from a high tunnel. That's in part why the pH was so high.
Okay.
And so one of the things that this farm was doing was they had been adding a bunch of animal-based compost year after year after year, and all that dairy manure drove the pH way up and their fertility levels way up. That's why they had so much excessive calcium and they had so much excessive phosphorus, higher salt levels, and they had really high pH as a result of all that composted dairy manure that went into that tunnel. So in that case, yeah, they were just feeding through the drip. Tomatoes are really, really well understood in terms of fertility and their tissue testing. Tissue testing is a great tool. I recommend that growers who are struggling with their fertility tissue test at least twice a year. So the first time you want a tissue test is about 4 weeks after transplanting. And the second time you tissue test is when your first fruit are tiny, like not quite golf ball sized. And so those two tissue tests give you two very important life stages. The 3 to 4 weeks after transplanting is when that plant is about to enter its rapid vegetative growth phase. And when the first fruit are not quite golf ball size, that's when you're making that shift out of vegetative focus into reproductive focus. When you tissue test, you want to tissue test exactly as the lab tells you. Oftentimes that's taking the first fully expanded mature leaf. That tends to be about the 5th leaf down from any tip. And you do count the little teeny tiny leaf. So 5th or 6th leaf down. You want to do it when the plant it's got great water status, so that leaf snaps right off. And then you want to make sure that you rinse anything off of that leaf surface and then pat it dry before you put it in the bag. It's not hard to do. It costs less than $20, including shipping. And at those 2 times, you still have the ability to correct any problems. And the tissue testing shows you problems before you would see it in the plant. So this is an example of a plant where you definitely would be seeing the issues. Big deficiencies in nitrogen, big deficiencies in calcium or potassium, manganese. This is that same tunnel that had the very high pH, so we're expecting a manganese deficiency driven by pH. Excessive levels of calcium, as we would expect from all of that. The copper levels, this happens when people forget to rinse off their leaves, and so the copper they were spraying on the plants stays on the tissue test. So you do have to do a little bit of interpretation here, like, oh yes, I forgot that, not that I have so much calcium, or copper, I forgot to rinse it off. But the tissue test tells you things before you see it, particularly for potassium. And over the course of the season, it becomes a very, very good management tool. So the way that we read this chart, we have 5 different sampling dates across the bottom, starting in the middle of May to middle of June or middle of July. This is a high tunnel from a study that was done a couple years ago. We have all of the macronutrients across the bottom. The green is the top of the sufficiency range. Red is the bottom of the sufficiency range. And you see that the range shifts. The first solid bars, those are for the vegetative stage. And all of these macronutrients, the plant's physiological need for them is shifting as it moves into fruiting and reproductive stage focus. The blue are the levels of nutrition available in that plant. And yes, the tissue test is a look backwards in time, but it is far better than waiting for the plant to color up. By the time the plant colors up, you've had so much damage that you've already lost the yield. Tissue testing helps you prevent some of that. So we saw the nitrogen levels falling, they dipped too low. Grower changed their fertilizer blend. Potassium, same thing. That start dipping down, they change their fertilizer blend. So it's useful over the course of a season. And then just re-emphasizing that point, if you don't rinse the leaves off, you can see really big spikes in copper, and that's just you sprayed copper and forgot to rinse it. So foliar testing is a great tool for nutrient management. Really quick, I'm going to go through recognizing deficiencies. I'm going to do this quick because there are so many good photos on the internet. This panel I have right here is kind of like, it's old, it's dated, but it is the classic panel. So it's very easy to recognize these photos. They all have that kind of fridge magnet style look to it. So if you're on the internet, you're like, is this really that deficiency? Check it against these fridge magnet type images when you're searching. So nitrogen's a mobile nutrient. When it's deficient, it's the lower leaves, they're yellow, the plant lacks vigor, it's a weak plant, very common for us to see. More in tomatoes, we see excessive nitrogen. That's when you get this very dark, bushy, lush, beautiful plant that doesn't flower, that doesn't set fruit. Because you've got all this bushy plant, because we tend to trellis our tomatoes, all that material gets packed in, it gets wounded when it gets packed in, you don't have good airflow. And we see a much higher incidence of botrytis when we have excessive nitrogen. So managing nitrogen is actually an IPM tactic for botrytis. It also tends to reduce the attractiveness of your tomatoes to aphids. IPM tactic. This is botrytis directly attacking foliage, but it also leaves these dough spots on the fruit. And if you've ever had fruit where it starts this softer rot off the blossom end, that's botrytis getting in there. Botrytis will hit the tomatoes at the flowering stage and then wait until the tomatoes mature to rot it. When it goes directly after the foliage, it's very hard to stop, and we can lose tomato crops and I've seen many tunnels go down to botrytis. Potassium is a mobile nutrient. This is the one that you really want to watch. It's very important physiologically for loading sugar into the plant, okay? If you can't have the sugar getting into the phloem to distribute around the plant, then you're not going to be growing very well. That means you're looking for scrawny tips to the shoots. You're looking for flower abortion, like we see in this photo here. You're starting to see yellow shoulders develop on the fruit that are maturing. In really severe cases, you'll get a purpling across the leaf surface. The whole plant is suffering, and you can start to see other secondary nutrition symptoms show up. Potassium is the one that you're watching with the tissue test more than anything else, because it's more of an invisible deficiency. By the time you start seeing the signs of it, you've already lost yield potential. And you've definitely lost quality. Really poor flavor, yellow shoulders, that's usually potassium, a little bit of a magnesium thing. So if your flavor is not where you want to be, try adjusting your potassium magnesium. Phosphorus, phosphorus is very common. It's not that available in cold soils. Remember earlier I said that most labs will recommend a little bit of phosphorus, even if the levels are just out of this world, sky high. It's because cold soils, phosphorus is in it, but the plants can't get it. Part of that is because there's a fungal intermediary that helps to collect a lot of the phosphorus. When soils are cold, the fungus is not all that active. It means that it's very common, and it's a temporary thing that we see in transplants. It's a reddening or purpling on the undersides of the leaf. So you flip that leaf over and all the veins are coloring up. We can most easily resolve this by using a little bit of phosphorus in the transplant water, or by using raised bed plastic mulch to get it warm. Now, phosphorus is really important for root growth. So that's why they're recommending it. Is yes, the soils are cold, but we also need to really quickly establish roots. So feed the phosphorus early. As we go through the summer, their need goes way down, and particularly in tunnels where phosphorus tends to build way up, or in organic farms where you're using a lot of animal-based inputs, phosphorus levels get quite high. You can pull the phosphorus completely out of your summer drip program. The soil will supply it. If you have a soil that is very low in pH, or you have soils that are naturally very high in aluminum, a lot of shenangos are very nice agricultural soils, but they're naturally very high in aluminum. Know that phosphorus is inhibited by excessive levels of aluminum in the soil. In those cases, when you have very high aluminum, you do want to feed phosphorus through the summer. And phosphorus is loaded into the leaves first, so you may see that color hang on the old leaves. You're checking the new growth for improvement. Magnesium, another macronutrient. very, very common to see some deficiency in magnesium. It's a mobile nutrient, so the plants will reallocate it from low in the plant up to high in the plant when they're a little bit deficient. It's interveinal yellowing, so it's spotting between the leaves. With age, you can see here, they start to get a little bit of a bronze spot in the center of that. Purple or bronzing in the center of the yellow in between the veins, that's magnesium. This isn't something to get excited about so long as it's in the bottom part of the canopy. It's natural. You're really wanting that to stay good in the middle. So with magnesium, we divide the plant in thirds. If it's in the lower third of a mature size plant, not a big deal. If it starts creeping up or getting more severe and heading towards the middle third, you want to be managing that.
Elizabeth, we're getting tight on time, just to let you know. About 2 minutes left.
Okay, thanks. So just a side by side, this is a tunnel that had a lot of fertility problems, not caused by lack of available nutrition in the soil, but caused by problems like severe compaction, too much salts. They had other factors inhibiting their fertility uptake. So we've got a severe potassium deficiency. Once it gets this bad, that's coloring up the foliage. We tend to see it make other nutrient problems even worse. Calcium deficiency will color up the edges of the leaf, and it's a fairly bright coloring up of the edge. Calcium deficiency does not, calcium doesn't move through the plant, so you'll see it color one age group of leaves. The next age group of leaves won't have it, but that age group will never get better. You'll have that for life in that age group. What you're looking is for improvement. This is magnesium as it gets more severe, and this blossom end rot, a lot of people will say it's calcium, but it's not. It's actually water. You didn't have enough water to move the calcium to the fruit. So calcium level is fine, inconsistent watering. These are the most common nutrient deficiencies. They do lead to weak plants. They do cause other IPM problems as you go down the road. And once you get these gross overall nutrient deficiencies, just one final photo, you can see all the disease in here, all the decay, all the rot, and also some really cute birds. So on that, we're gonna end the presentation. I'll stop sharing. And if you have any questions, please drop them in the chat.
So there is one that just came into the chat. Do muck soils have an effect on tomato fertility?
Okay, yeah, great question. So muck soil is incredibly high organic matter soil. It's formed from like dead plants and trees and stuff, really old swamp. Because of that, it holds so much more nutrition per unit of soil. So if you have like a cup of soil, it holds much more nutrition. Because it holds so much more nutrition, the actual pH, because it holds so much more nutrition and because the soil naturally sits at a lower pH, all of our values, if we say tomatoes like pH 5, there's 6.5 to 6.8. You adjust that downwards almost one whole unit when you're working on muck. And that's because the nature of the soils, A, they run more acidic, B, they can make up for it by holding so much more fertility. So if you are testing a muck, it's going to, show low. That's okay. Don't be freaked out by that. You do have to watch some of your micronutrients a little more closely because some mucks don't have a lot of that. Depending on where you are in the state, if you may have a muck that's underlaid by a lot of calcium, and that will change your fertility management. If it doesn't have the calcium underlay, you tend to be very high in sulfur and you need to supplement calcium there.
This has been a production of Cornell University, on the web at cornell.edu.